are. This is the camera head on Spirit, and you can see that it's almost my height, and that's intentional. These are the cameras up here, and they're about the same height as my eyes, so that the pictures we get from Mars will look the same as though you were standing there looking around. Now, it's a wheeled vehicle, and basically it's a radio-controlled car. Something like this. Now, I know it doesn't look the same, but the principle is the same. The car has an antenna. Spirit has several antennas to communicate with Earth, and there's a controller. Now, how do you control a radio-controlled car? Well, you turn a joystick or a trigger, and it goes forward, backwards, turn, left, right. Whatever you do here, it hears over here. And it's all happening at the speed of light. Well, there's one big difference when you're talking about a Mars rover. The rover is on Mars, the controller is on Earth. So when you say, go forward, the radio signal from Earth takes 10 to 20 minutes to get to Mars. So the rover doesn't hear it right away. So it's going to take 20 minutes from the time you say go till this thing actually starts to go. Then if it's heading along and it comes to a big cliff and you say, stop! It won't hear that for 20 minutes. So it means it'll go over the cliff. That means that these rovers have to be fairly smart. So they kind of treat them like dogs. So the rover looks around, and the people on Earth say, hey, you see that rock over there? Why don't you go over and take a sniff? And the rover does that and tells us about it after it's done. They're fairly smart little beasts.
It's so far away that you actually have to plan everything out the day before. You have to carefully, send those commands up, make sure they don't do anything bad to your spacecraft. And then you need to give your rover enough sense that it won't put itself in harm's way. So if it sees a rock that's too big to go over, it will actually stop and try to go around it. If it sees the edge of a precipice that it might fall off of, it will stop and wait and call home. Okay.
Really?
Yeah, it has to have enough sense or else it would kill itself. I mean, it doesn't, it's just a bunch of metal, It doesn't know any better.
Okay, so it's not entirely stupid then.
It's not entirely stupid. It has a whole series of sort of insect-like commands. It says, if this, then this, if this, then this. And that tries to keep it safe, and you can actually set those parameters. So how much the wheel actually goes up and tilts, how much the bogey tilts, how much the whole spacecraft tilts. And that keeps it safe but even so, you carefully determine a path. You give it X, Y's to go to, and locations, and you tell it all the things to do with these instruments. Now, it's very difficult to do that because you're so far away. So basically, you're stuck on Mars time. That's really the operational scenario. These things are solar powered, so they wake up in the morning and they go to sleep at night. So at the morning, we've got to be here. We're ready. In the morning, we send up the commands that we decided yesterday, and we told it what to do for